hopefully a great presentation and make wetlands your Valentine today. And we appreciate you taking the time to come and be with us today. I'm Mike Murray. I'm the Executive Director for the Bow River Basin Council, and I will be your moderator for this lunchtime. So first, I'm just going to go over oh, that's not what I wanted to do. First, I'm just going to go over the welcome, the housekeeping, of course, the land acknowledgement, and our intros and speakers. We're going to have then a present set of presenters, and then we're going to have some questions at the end. So, and in the background, we'll have Brooke, who's working some of the IT stuff. So if you do have any challenges, please try to get a hold of her through the chat, and she might be able to help you out. So the first order of business is to do our land acknowledgement, and we are pleased to gather today with the assistance of technology in the traditional territory of Treaty 7 in Central Alberta, which includes the Blackfoot Confederacy as well as the Tsuut'ina First Nation and the Stoney Nakoda. The Bow River Basin is also home to the Métis Nation Alberta Region 3. The BRBC respects the histories, languages, and cultures of all Canada's First Peoples and acknowledges that their presence continues to enrich our vibrant communities. So as I mentioned, if at the end of the day, there's going to be a Q&A, and if you could please use the Q&A button, not the chat button, for putting in your questions that you wish to have answered at the end, that would be useful. For those that want to kind of get a few bits of discussion underway, the chat function will be good for that. But if you want your question to be asked at the end, the Q&A function button is the best way to do it. If, of course, that's not possible for some reason, you can put it in the chat, and hopefully Brooke might be able to copy that into the Q&A after. This webinar is being recorded so that those that were not able to make it here today can go ahead and see it again if they so wish, or go back to their favorite moment of the lunch hour. And of course, for all questions, especially super hard ones, please go to Nilo, and her address there is below. So yeah, feel free to ask any question. I'm sure if it's possible, they will get back to you as soon as possible with an answer. So the first thing I want to do is just introduce Ms. Stacky to the rest of you. I think everybody on this call already knows, but the Mistaki Institute is a charitable applied conservation research institute affiliated with Mount Royal University. The Mistaki Institute brings people and ideas together to promote and maintain healthy communities and landscapes. And the two speakers that we have today are Nilo Sinatambi and Sarah Jordan McLaughlin. So Nilo is a manager of conservation research with the Mistaki Institute. She fell in love with wetlands as an undergraduate student on a field course and went on to study some of the wetlands in the Peace Athabasca Delta for her master's. She took a detour to study fish for her PhD, but is very happy to be able to work with wetlands again. Nilo has been a volunteer with the BRBC Science Council for almost 7 years. And Sarah Jordan McLaughlin is a conservation analyst with the Mistakis Institute. As an avid birder and amphibian enthusiast, wetlands are one of Sarah's favorite places to be. Working as a naturalist with a local nonprofit, Sarah has also gained experience with invertebrate sampling and talked with various audiences about the benefits of wetlands on the landscape, particularly for biodiversity. Last summer, Sarah led the fieldwork for Mistaki on an amphibious eDNA project in the Calgary region. So I know we've got a short period of time to get a lot of information out to you. So with that, Nilo, I'll hand it over to you.
Great, thank you. And I will share as soon as I can there. Okay. Oh, always takes a minute here. Can you see that, Sarah? Okay, Sarah and I are in the same room today, so that'll help us here. Hey, so thank you everyone for joining us today and for not being scared away by the name of our webinar. And thank you, Mike and Brooke, for the introductions and for hosting this event. And we'll jump right into our topic, as we know we have a lot to cover today. So I'd like to begin by acknowledging our partners and funders. Thanks to the City of Calgary, an anonymous funder, they funded this work. We got all of our imagery that went into these data sets provided by the government of Alberta. The data sets themselves were developed in partnership with Fiera Biological Consulting. Again, thank you to the BRBC for helping us share the information about this data set to a wide audience. And we also involved a volunteer advisory committee. And so thanks to them for providing a lot of input along the way. So the goal of this project was to provide consistent, high accuracy spatial data representing wetlands in the Bow Basin. And this project really stemmed from a need expressed by municipalities in the region at a workshop back in 2020. And the idea was to build this resource so that it could be shared by municipalities largely to help support land use planning, wetland conservation, and restoration. And the idea is that it's a shared resource, water to manage in this area. And so it would help even out some capacity differences around this region. So this slide shows the Bow Basin in the solid blue there. The outline in the light blue is the actual study area. And so when designing this work, we extended the region of the study area so that we could capture some of the actual jurisdictional extents of those counties and municipalities that were involved. So in total, the study area is 35,787 square kilometers, which is 5% of Alberta, which is kind of a large undertaking for a study of this kind. It is a really interesting area because it's the most populous basin in Alberta. It contains several municipal districts, counties, cities, towns, and First Nations reserves. It also has a diversity of natural regions, including Rocky Mountains, foothills, parklands, grasslands, and it also has a variety of land uses. So forestry, recreation, all of the sorts of activities that happen in municipalities, and agriculture, just to name a few. So to meet this goal of supporting land use planning and wetland management, we developed these 4 data sets. And I'll go into them more in the next few slides, but just to introduce them in general, the first is land cover. The second is wetland inventory. The third is potential restorable basins. And the last is the historical wetland inventory. So before you use these sorts of data sets, it's really helpful to understand where the data comes from that goes into the creation of them, because that really controls their limitations, which then affects how they can be applied. So the land cover and wetland inventory use spot satellite imagery and LiDAR data. This slide shows the size and shape of the image tiles that went into those products, and the dates. Those numbers on there include the dates that were included. So when Fiera Biological Consulting went through all these images and had to determine what to use, they were looking for what was the best available in terms of just the quality of the image, from considering things like cloud cover and atmospheric haze, but also things like season. So apparently there's a sweet spot where you want things to be green, but not too green, to be able to capture all of the spectral information that you're looking for to go into these data sets. And there was also LiDAR cover that covered most of the study area. There was just a small portion, I think towards the west end of the study area, that didn't have any LiDAR coverage. So this is the first data set that we'll talk about, the land cover data set. Land cover, just as if you're not too familiar with this sort of data, it's a spatial representation of the land surface, and it usually includes a mix of land use like agriculture, but then also land cover like deciduous forests. And in these days, it's typically built using machine learning, and it predicts the classes or the cover classes based on a model that's developed through machine learning. So I don't have too many diagrams that look like this in this presentation. This comes directly from the technical report that Fiera Biological Consulting created to go alongside these products. And so I just wanted to show this one so that it helps set the stage of how these sorts of data sets are created. So you get multiple different inputs that go into creating these a model. So LiDAR, different types of satellite imagery, and then you'll get a training data set as well. And all of those feed into this random forest model that then are used to produce a predictive model. And that's what produces your land cover data. And then there are validation steps and semi-automatic and manual cleanup procedures as well. So it's really quite involved and took many, many hours by Fiera Biological Consulting. So the output of the land cover data set, I guess it's not the output. They designed this this land cover layer to have two levels of hierarchical classification. So level 1 is more broad scale, more general, and it includes things like forest and natural depression. Level 2 is more fine scale, and it'll like then split up your forest into coniferous and deciduous, so you can get more detail in terms of what sort of information you're looking to work with. And the thing that I wanted to note about this land classification scheme, from what I understand with these sorts of things, they are usually built differently depending on what type of data sets you're trying to produce. And so when Fiera set out to think about how to represent this in terms of spatial data, they really spent a lot of time making sure that it was suited to feeding into the wetland data set. So they spent time delineating between upland and lowland, and then having that whole section in the lowland part of the natural depressions that were then divided into all those different vegetation types. And I also wanted to call attention to the agricultural depression. I think that's fairly unique as far as land cover classes go. And so this particular item, it's a situation that you'll see where it's usually a field, like an agricultural field that has a depression in it and it has wetland properties. But more often than not, the water levels are low enough that often producers will cultivate those areas anyway. So it's sort of both things. It's agricultural, but it's also a wetland. And we didn't make the distinguishing decision here, but the users can then have that information when they're working with the data set. So this is this shows the second classification level, the more detailed one for the entire study area. And you can see that we start with kind of bare ground in the Rocky Mountains, moving into dense forest. And as you move east, you go more into cropland, and you see those bright pink human-built areas. So it kind of matches what we know this area to look like. So some considerations with working with any of these remote sense sort of data sets, there's always things that should be considered when you're using it. So for this particular layer, there's boundary accuracy because it's a pixel-based process that's used to develop this data set. As you zoom in further, you start to see kind of jagged edges around the edges of whatever feature you're looking at. So it just limits how you would use it. You wouldn't use it to delineate the boundary of some specific thing, because that's not really what this data set is meant for. Similarly, the minimum mapping unit for this data set is 200 square meters. And so that's sort of the resolution that you'd expect to be looking at with it. Another thing is difficulty to differentiate between some land classes. So these are just things that kind of look similar. So you'll expect to see some error between those groupings. So the next layer is the wetland inventory. So this one is built right off of the land cover classification. So out of those land cover groups that were open water, natural depression, and agricultural depression, those were the pieces that then got fed into the wetland inventory. And those areas were then further classified based on vegetation type. So to determine whether they were graminoid or woody, and that would have been based on like spectral information. And then those land class informations, or the pieces of it, would then be converted to a wetland object or a wetland class for that object based on the Alberta wetland classification system. And so this process that we used, it satisfies the Government of Alberta's wetland classification requirements. Something I just wanted to spend a couple more minutes on is that idea of having different areas defined within the wetland and then translating it into one class for each wetland object. So when you download the data sets, there are two different shapefiles for the wetland inventory. There's the wetland with cover info, so that's the land cover layer. And so that's what you see on the left-hand side there, where it shows like one wetland. You'll see the outer green ring, which is the lowland mineral graminoid, and the inner center is the open water in one of those areas. And then this is the same area on the right here, and that's how it would look with the other shapefile, which is the wetland objects. And so it was sort of a crosswalk between, you have this percentage of this kind of land cover and then this other percentage of like open water. And based on the Alberta wetland classification system definition, which I have just here in the corner so you can get a sense of what that looks like, we translated that into a wetland class. So this is what the full wetland data set looks like for the study area. And just you see general changes, like in the west end, you see more fens. As you move east, you see more marshes. Remotely sensed data is flawed always. There's always limitations around the accuracy when you're working with it. And so validation steps and assessments of accuracy are always part of this process. So I just wanted to show the results of that analysis that were done for the wetland data set. As is typically expected, the ability for these models to pick up the difference between wetland versus non-wetland are pretty good. They're in like the high 90s. And then as you start to try to differentiate between different types of wetlands, it gets trickier and you get typically lower percentages, but even still, it's pretty good with an average in the 80s here. I just wanted to point out the swamp one. It's fairly low, or the lowest out of the rest of them. And the reason for that is because they can be really easily confused with marshes with a woody riparian band around the edge, and also with treed fens. And you can only really tell the difference between those if you are out in the field and look at the soil. So a couple considerations for use with this data set. It's similar to the land cover data set because that's what it's built off of. So there's issues around boundary accuracy as well. And the minimum mapping unit for this layer is 400 square meters, which is, it meets the government Alberta standards for wetland data sets. And again, the confusion between swamps, marshes, and treed fens should be considered. So there are a few different wetland inventories out there. There's the ABMI's wetland inventory, there's the Alberta merged wetland inventory, various municipality-specific inventories that they would have made for their own purposes. So I just wanted to go through some of the differentiating pieces between this data set and some of those. And so one is that we removed rivers, dugouts, and reservoirs, things that are not always considered wetland features. Another is that in the process of creating this data set, FAIRA did include some of the best mapping data available from other inventories. So they brought in some of those pieces and incorporated it with this data set as well. The other was that piece that I focused in on a couple slides ago, where I mentioned that we have one wetland class for a wetland object. So some of the other data sets we've seen, they keep the different pieces labeled differently. So then the user would have to take that information and then use the Alberta classification system and determine the wetland class for themselves. So we sort of have both pieces in this data set. The other thing that we really see as a bonus for this is kind of that seamless data set across the region, where you don't all of a sudden have different methods or different input data that goes into an inventory. And this, we hope, will help with things like regional planning, where you're not going to see differences that are caused by the data. And then the last that I wanted to point out is that a disturbed attribute. So this goes back to that agricultural depression land cover class that I focused in on several slides ago now. We've incorporated that, all of those as wetlands in our wetland data set, but there is an attribute that indicates, like there's a field that indicates whether it's disturbed or not. And so the user can then decide whether they want to include those wetlands in whatever the work is that they're doing or not. So on to potentially restorable basins. These ones were identified not using like the same spot or satellite data that we mentioned in the past. So it has a very different method of how they got to this, but it identifies drained wetlands that have a high likelihood of qualifying for restoration based on AEPA's wetland restoration program. So these are ones that are typically, they show evidence of a man-made drainage ditch. And the way that they were identified was by people like Fiera looking at ESRI base map images and Google Earth time series images and ABMI's historical imagery too, and just scanning through the photos and looking, just manually searching out these potential spots. And so it identifies quite a few over 13,000 potentials, but I should really highlight that it is a very tricky process. So it's not guaranteed that these are going to be restorable or that they will meet the requirements for funding, but it's a great place to start. So I guess speaking of that, considerations for this data set is that it really can be hard to identify these just beyond the man or person power that goes into it, the time spent. Particularly in highly modified areas, it's hard to tell the difference between natural drainage versus human-made drainage. And so those can cause issues with this data set. As well, there's some areas of the province or sorry, the study area where they use tile drainage as well. And so those aren't visible from above ground. And so those aren't included in this data set. A decision that they made when they made this data set is that we included both the drained and the receiving basins. So sometimes you'll get a chain of natural wetlands in a row, and it's some of the upstream ones that have been drained to kind of amalgamate into a larger downstream receiving basin. And so for this data set, it includes all of those indicated as being potentially restorable basins. And the idea there is, though, only some of those have been drained, even the receiving basin has been impacted by this process. There are definitely some instances with this data set where you'll see, if you compare between the different layers, you'll see that there isn't an overlap between one of these points and a historical or a current wetland. And so there are a couple of reasons why something like that could happen. One is that is just an error. It's just this vast area where this was a really challenging process. And then the other is that it's just a highly modified basin. So there was strong evidence for a drainage basin, but the current or the area that exists now doesn't really show any evidence of a wetland at present. So lastly, for the running through the data sets here, is the historical wetland inventory. And I feel like as we go through these data sets, they're getting a little bit more challenging, and kind of they'll have more limitations because our confidence around this historical one is going to be lower just because of the challenges of creating something like this. So this also was not built off the spot imagery, but from black and white ortho photos from 1949 to 1951. And again, this was the most challenging part of this data set creation. And it has limitations based on things like matching up the different ortho images that went into it, and something around like the projections, and I'm gonna mix these ones up for sure. And so I don't want to spend too much time talking about those limitations. It's really well laid out in the technical report. And there are strong recommendations that you really consider how to use this data set in particular. So I think most people they want to layer the current wetland data set over top of the historical and see how things have changed. And we don't think that it's a good use of this data set. It's not about comparing before and after in like one specific spot, but it can give a general sense of how a certain area within the study area used to be in terms of the density of wetlands compared to how it is now. So you don't want to look at, oh, this wetland was there now and now it's gone, or it was bigger and now it's smaller, but more of a general, a regional sort of assessment. So application ideas. There are so many ways we think that people will find these data sets useful. And part of the work that we did with the advisory committee helped us understand some more applications even that we had come up with. So here's just a few of them. One is state of the watershed reports or establishing baselines. One is identifying restoration opportunities. Another is regional planning, again, to make use of sort of that seamless data set that exists here. And connectivity modeling. We know that some people have already been digging into the data sets and using it for that application, and identifying where at-risk watersheds are. So bringing in that idea of from the historical layer of like, this is what this watershed looked like before in general in terms of the density of wetlands, and this is what things look like now. So which areas have seen the greatest loss? And I'm shockingly running a little early here, and I'm going to turn it over to Sarah, who's going to introduce you to the actual website. So I'm going to stop sharing.
Website.
Yeah.
All right, so I get the fun job of showing the website. So this is your basic front page of the website, and there's 4 little tabs that you can go through. This is our home area, where we kind of give you a little bit of information that Nilo has just gone over, an introduction and all of the what each of those layers are. And then it also shows you that spatial extent of the Bow River Regional Wetland Datasets, again, incorporating all of those counties and MDs, not just the ones in the watershed specifically, but to give a greater advantage to anybody that would like to use these datasets. In our About section, again, a little bit more detail about all of these and links to other data sets as well, and that technical report, which you will also find under our resources tab here. So this is the full technical report. It's got quite a lot of information, so make sure you've got a lot of coffee with you to read it and you're ready to take some good notes. But if you are curious about more in depth about how these came about and the limitations and what they could be used for, this is a great resource for you. But for more fun, let's go to the data sets. So the data sets themselves, when you click on them, it will take you here. This is a GIS experience, so you can both download and play on the website as well. And again, it refers you to the resources page for that technical report. So if at any time I wanted to go back to the website, I just click this. And if I would like to download, and we'll look at that in another second here, I can go here. But let's look at the fun stuff. So we can see already, as soon as you go to this dataset page, it will highlight the current wetland inventory. So here's our current wetland inventory. To go to any of the other layers, I can come into here and I can move this screen all around. That's that drag me there. Drag me because you can drag this all over the place. And this is where you're going to find your different layers. But if you don't like this base map, before you begin anything else, you can change your base map if you would like. And it gives you many of the same ones that you're going to find in ArcGIS as well. Personally, I like this one, so I'm going to work on this one for this demonstration. So we have our wetland inventory highlighted. And then we could also look at the other 3 data sets or potentially restorable basins. Whoa, that's a lot of red dots that come up. And again, take those with a grain of salt. They're not perfect. Everything should be ground truth before you take it into any planning sessions. Historic wetland inventory is going to be hidden under that potential one. So I'm just going to tick that off. And just for fun, I'm going to take off the current one and show you have to zoom in a little bit, this historic layer. Sometimes I like to play a little game where I've played on this way too much. And I have the wetlands and the historic, and I take off the historic and then I put it back on. Again, this is not hey, this was the extent of our wetlands. This is just to give you an idea, and everything should be ground proof before you make any planning decisions. But it gives you an idea. Nalo did have my neighborhood highlighted on her slide there. So I just wanted just for fun. This is my fun little game I play. So I like to come over here and I say, look at all those wetlands. Oh, they're not there anymore. But that doesn't mean that they were necessarily all there. It just gives kind of an idea of where likely water used to like to be. And there's that land cover again. So it gives you that built up area, and you can see all of the disturbed areas in Calgary. You can see that pasture land in yellow coming out this way. So it is a lot of agriculture and grassland. Again, it can be hard to define between those layers definitively. And then you can see the forest layers as well over here. But that's not all you can do with this. There are a lot of other layers. So you can see in here, I could highlight national parks, public land use zones, green and white zones, municipalities, all of these things in here. And you can also go even deeper with linear features. You can get roads, you can get pipelines, railways. You can highlight lakes and rivers, which again, it was mentioned that those were taken out of this main data set, but you can put them in when you're playing around with them. You can also put the hydrologic unit code boundaries in here. So you can go to basin, sub-basin, or sub-watershed as well. You can look at different soil groups, which is great if you're looking at different land use planning. And you can also do the Alberta flood mapping. So this one's kind of cool because you can see where the flood fringe is, where the floodway is. You can see where there's overland flooding likely, and you can also see areas where maybe it's data deficient at this point. So over in the elbow here, we actually don't know what this is, and it will tell you that. So any of these layers, you can click on a specific object within them, and it will tell you what you're dealing with. So this tells you this is under review, and it's open water. And then that will tell you this one is flood hazard, flood fringe, and the overland flow. So that's kind of a cool use of this if you are looking at different combinations of layers as well. And just to give you an idea of a way that I'm personally using this, so it was mentioned in the introduction that last year I helped with some amphibian eDNA work with Mistaki, and once again, we're doing another season here. And so I want to look at the greater Calgary region, and that's going to be incorporating 2 different municipalities into my data sets. So I want to add in my land cover and my other layers here. So I want to look at my municipalities. So around Calgary, I want to know if I'm looking at the Foothills County. Oh, there is Rocky View County, and here is my Foothills County. So I know I have 2 counties that are in my study area. So Foothills and Rocky View are my 2 counties here. But what if I want to highlight those? So I can come over here, and there's a lot of options. For the purposes of a presentation, maybe you just want to say, here's my study area, and you don't need to draw a boundary around it. But maybe I do want to draw a boundary around it. And I have a lot of different options within this that I can use, different colors for different zones, different transparencies as well. So you can change the transparency, and you can also change the thickness of it within that. So let's say I wanted to do this, and I can draw this around my whole study area there. Or I could draw a polygon. I could just, if I wanted to take the time, I can do line by line, and I could draw around this whole thing. I'm not going to do that for this purpose today, because that would be way too long. But if I want to erase anything I've done at any time, I can just clear that off. So I can do lots of different drawing there, but I can also highlight things on here. So if I wanted to highlight where a specific area is, I have all sorts of different icons I can use, and I can just place them on here. And within this seems like a lot, but there's a lot. So this can take some time to go through, and obviously we don't have time today to do that, but there is a ton of stuff that you can do. So you could say this is a fire zone, or this is a hazard zone. You can highlight things within your city, general infrastructures. You can show where hospitals are. You can show where all of these different elements are. And you can even go into all of these different systems here. So you could put point of interest in. You could do all kinds of fun stuff. But for me, for my purposes, I would be looking for wetlands that we could sample for our data sets, for our DNA sampling. So let's say I want to make sure that I'm into Foothills County, and I'm looking for a specific wetland class. So you can come in and filter your layers. So it must be in the layers visible range. So that gives you, you need to zoom in enough to see that. And sometimes with some of these smaller wetlands, you're not going to see them until you zoom all the way in. So you can see how this green one just suddenly showed up. That's because it wasn't at a fine enough resolution with the bigger one to show me that this is actually, if I click on it, oh, it's going to give me multiple options here. We're in Foothills County, yes. And if I go all the way in and I click on this now, I can see there's two different things. So it will tell me I'm in Foothills County, and it will tell me that this is a shallow open water wetland. And so that can be a really helpful tool to narrow down what you're looking at. If I only wanted to find marshes within my map, I can narrow it down. I can do that. And I can also do that disturbed. So if I want pristine layers that have not been disturbed by development at all, I could put, nope, I want no disturbed, or I can just say, I want any wetland that is classified as a marsh. And then I can kind of look around and look for these marshes. I can see one here. And again, it's going to tell me, oh, shoot, you're out of your study area. You are now in Vulcan County. So maybe I want to move back over into here and try this one over here. And again, this is going to tell me I'm in the right county. Click on this little one here. And two things, I'm in Foothills County and I'm looking at a marsh, just what I was looking for. And now I want to measure my marsh. I want to know how big it is to know how many samples we need to take. So I can go over to this measurement tool here, and I have two options. I can use just a ruler, if maybe I just want to go across the wetland, or I can draw a little polygon around it. So you just click it. And it's telling me that this is a lot bigger than you would think based on looking at it. So it's over 3,500 meters squared. But what if my measurement, I want to measure it in a different way? And then my little tool isn't going to work there. So I can measure it in imperial, square inches, square feet, all of these different ways. So you can have a variety of different measurements within that. So now I've decided that I would like to measure this, or I would like to sample this wetland. And I want to know how far it's going to be for the crew to get there. So what I can do is I can go into my map layers again, and that's where these other layers come in really handy. So I can go to my linear features, click that on, and I can click the road feature. And now I can see where the nearest roads are to this wetland. And then I can take my little measurement tool again. This time I can take that ruler and I can say, if we park here, how far will it be to get over to here? Oh, it's going to be about a 500-meter walk if all goes well for them. So that's not too far. So I can plan how far they have to walk. I can plan exactly where my wetlands are, and I can know the size and samples that I'm going to be using for that. So that's just one way that you can use it. And there are a myriad of ways. And this could take, like, you can literally spend hours on here, and I have. Look at all these roads. Isn't this amazing? Holy cow, if you zoom out, that's a lot of road density. And this goes with that connectivity modeling that Nalo mentioned. This can be used for connectivity modeling because you can look not just at the wetland data sets, but you can look at these roads and you can look at the impediments to wildlife movement. Especially if we're talking about something like amphibians where roads are a big issue. Look at all these roads surrounding all of these wetlands. And this is something we can start to model with. But I want to give a couple of other examples of how we could use these data sets. So I'm just going to stop sharing this and I'm going to share a different screen with you. So a couple of the other ways that we are working with groups to use these data sets. One is our host group today, the Bow River Basin Council, are doing their State of the Watershed report. And so these are reports that kind of give you an idea of decision makers and any interested party stakeholders about watershed conditions, local pressures, and potential data gaps or research needs. Now there are 20 sub-watersheds within the Bow River Basin. That's a lot of information to collect. So what they're doing is they are getting each of these sub-watersheds and groups within them, and also collaborating with researchers in the area to gather information and putting it into the ArcGIS Experience Builder so that they can bring all of this latest data in. And you can check out, there is an interim report on their website, but the main website or the main report is due in late 2024. But you can see who's already submitted things. There's already something for the Elbow River watershed, and a few others, I think the Ghost River and some other areas as well. And they can use the wetland inventory, so that current data layer, the historical and the restorable layers from the data sets, and that gives users options to explore different scenarios. So if you're a land use planner or a decision maker that needs to understand different ways, different pressures on a specific watershed, you're going to be able to zoom in and out and use these layers as needed to give you that information to make better decisions. And another way that this is being used is to support water investment within the city of Calgary. So in 2020, the city of Calgary created a source water protection policy. And with that, there have been plans for an upstream watershed investment strategy. So this is going to come with a granting program that's going to support on-the-ground projects to protect, restore, and enhance natural infrastructure to provide beneficial ecosystem services. So some of those ecosystem services may be flood and drought mitigation, maybe to support clean water, and maybe to support biodiversity, depending on who's looking at the data and what kind of outcomes they're looking for. And so they can use these data sets to support these achievable targets and decide who is going to get these granting opportunities. So just a couple of ideas that have been put out there on ways they could use these. So they could use the restorable wetland layers. So you can kind of see over here, again, all of those different icons that we could use within that on the website that I showed you there. You can change them. So all of these little triangles have been made the restorable wetlands. And you can put that in conjunction with disturbed vegetation, and then you can identify places that might be a good idea to invest in restoration or enhancement. Alternatively, you can use a different base layer and you can highlight disturbed, so you can look at these gray areas, or natural wetlands together, which is the green ones. And that again is going to help you support multiple targets. So you can prioritize those green ones for conservation, while the gray ones could be prioritized for restoration. And the ability to look at these together has that opportunity to prioritize together. So you're not looking at something separately and saying, is this a good spot? You can see what's surrounding it and whether or not that's a good investment for the city to make. And then again, this is going to give people the opportunity to maximize ecosystem services. So on the landscape, as we're looking ahead for drought mitigation this spring and summer, having the opportunity to see where water could be stored or where you could potentially create these basins is going to be a big asset, I think, going forward. And with that, I'm going to pass it back over to Milo, and she's going to wrap us up. I'm going to try and send it back over to you. Hang on. There's my stop presenting.
All right. Do you see me?
I do.
Okay. Thank you. So what's next for this project? We are continuing to enhance the data sets. Just from feedback that we got in working with the advisory committee, we're also working with a student from SAIT who's helping us build upon these data sets and add in some stuff that we felt and that the advisory committee felt would really make them more improved, like adding some of those stormwater ponds back in, for example. And we have more longer term plans to help to develop a methodology to estimate wetland condition that we would then add to these data sets. So right now, and I don't think we covered this just a moment ago, when you want to download the data, you'll click on the download button that Sarah had showed you, and it'll actually take you outside of our website because the data sets are being hosted on the on a Government of Alberta website for now. Actually, they'll continue to stay that way, but as we enhance the data sets, we'll eventually have a download portal on our website as well. And so the data sets themselves and the website will continue to evolve over time, and we'll build more case studies as well. We want people to have ideas of how they can use the data. And we felt like this would be a good way for people to share ideas across this region. And yeah, then municipalities will be able to, once we have the condition factor in there as well, they'll be able to use these data sets to help them prioritize wetlands for protection and restoration. So thanks again so much, everyone, for joining us. I'm going to pass it over to Mike. That's sort of the end of our presentation here.
Really close to the end of our hour, so I'm very conscious of everybody's time. So I just want to thank everybody. Thank you so much for attending and participating in the webinar. Some great questions. It will be recorded and will be available soon at some point. And as mentioned before, if there are further questions, please do send an email to any of the organizers, but Nilo's information was included, so she'll be happy to receive all those questions and then answer them immediately or as soon as possible. So thanks, everybody. And I hope you enjoyed making Wetlands your Valentine today. So take care and have a great rest of your day. Bye for now.